minimum pulling force applied obliquely to a body to move it on a rough surface. Minimum pulling force applied on a body, minimum pulling force applied on a body obliquely placed on a rough horizontal surface. Minimum pulling force applied on a body obliquely placed on a rough horizontal surface. In the diagram, we have a block which is placed on a horizontal rough surface. mg is the weight of the body. mg is the weight which acts vertically downwards. M is the mass of the block and mg is the weight which acts vertically downwards. And along this direction, a pulling force is applied. Fex is the pulling force which is applied to the body at an angle theta with the horizontal direction. Now we can consider the two rectangular components of this pulling force. Horizontal component or the rectangular component of this pulling force in horizontal direction is Fex cos theta, and the rectangular component of this pulling force in vertical direction is Fex sin theta. Now we can denote the normal reaction force on the block of mass m applied by the horizontal surface. R is the normal reaction on the block or on the body of mass m applied by the horizontal rough surface, and we can denote the limiting friction. Fl is the limiting friction. This is the direction along which limiting friction Fl acts. Fl is the limiting friction acting on the surface in contact between the block and the body. The pulling force applied on a body of mass m, the pulling force applied on a body of mass m obliquely at an angle theta with the horizontal rough surface is given by Fex is given by Fex is equal to mu mg divided by cos theta plus mu sin theta. Fex is equal to mu mg divided by cos theta plus mu sin theta. That is the pulling force. That is the pulling force applied on a body obliquely at an angle theta with the horizontal direction. And Fex is equal to mu mg divided by cos theta plus mu sin theta. That is the minimum, that is the pulling force applied on a body of mass m obliquely at an angle theta. Fex is equal mu mg divided by cos theta plus mu sin theta, which is the pulling force applied obliquely at an angle theta with the horizontal direction. If the pulling force Fex is minimum, then its denominator cos theta plus mu sin theta will be maximum. Its denominator cos theta plus mu sin theta will be maximum. If the force or pulling force Fex is minimum, in that case cos theta plus mu sin theta, in that case cos theta plus mu sin theta will be maximum. Cos theta plus mu sin theta will be maximum. Therefore, cos theta plus mu sin theta will be equal to constant. If cos theta plus mu sin theta is maximum, that will be constant. Therefore, dd theta of cos theta plus mu sin theta equals 0, or dd theta of cos theta plus dd theta mu sin theta equals 0. Now dd theta cos theta becomes minus sin theta, plus mu is taken outside dd theta. Mu dd theta sin theta is equal 0, where mu is the coefficient of static friction, and Fl, limiting friction Fl is equal to mu into r, where r is the normal reaction, or minus sin theta plus mu cos theta equal 0, or mu cos theta equals sin theta, or mu equal tan theta. Mu is equal to tan theta, where theta is the angle with which pulling force is applied. Again, coefficient of static friction mu is equal to tan theta L, where theta L is the angle of friction. mu is equal to tan theta L, which is equation 2, where theta L is the angle of friction. Theta L is the angle of friction. Therefore, tan theta is equal to tan theta L. Comparing equations 2 and 3, we get tan theta as equal tan theta L. Therefore, theta is equal to theta L. Theta equal to theta L, equation 4. Now, the expression of pulling force is Fex, which is mu mg divided by cos theta plus mu sin theta, or comma mu mg divided by cos theta is taken common, 1 plus mu sin theta by cos theta, equal mu mg divided by cos theta, bracket open, 1 plus mu into mu mg divided by cos theta into 1 plus mu into mu. Under bracket, since sin theta by cos theta equal tan theta is equal mu mg divided by cos theta plus 1 plus mu square, Fex is equal to mu mg divided by cos theta plus 1 plus mu square, as tan theta equal mu, cos theta is equal to 1 divided by root over mu square plus 1, equal mu mg divided by, in place of cos theta we can write 1 divided by root over mu square plus 1 into 1 plus mu square, 1 divided by root over mu square plus 1 into 1 plus mu square is equal to, so therefore Fex min, minimum pulling force Fex min is equal to mu mg divided by root over mu square plus 1, Fex min is equal to mu mg divided by root over mu square plus 1. This is the minimum pulling force on a body applied obliquely at an angle theta with the rough horizontal surface. Fex min is equal to mu mg divided by root over mu square plus 1. That is the minimum pulling force applied obliquely to a body. Again, Fex, that is the pulling force, Fex is equal to sin theta L divided by cos theta minus theta L into mg. If the pulling force under bracket Fex becomes minimum, if the pulling force Fex becomes minimum, in that case theta will be equal to theta L, that is the angle theta will be equal to angle of friction theta L, and we get Fex min as equal sin theta L divided by cos 0 degree into mg. Therefore, Fex min is equal to sin theta L into mg. Fex min is equal to sin theta L into mg, where theta L is the angle of friction and theta L will be equal to the angle theta with which the force is applied to a body obliquely with respect to horizontal rough surface. Fex min is equal to sin theta L mg. That is also another expression of minimum pulling force applied on a body obliquely with respect to the rough horizontal surface. Fex min is equal to sin theta L into mg. Similarly, another expression of pulling force is what? Fex min will be equal to mu divided by root over mu square plus 1 into mg.